This is a little experiment to compare the writing speed to a Class 4 SD card and a Class 10 SD card. What we have here is a little signal generator. I'm currently generating, as you can see down here on the scope, 10 kilohertz signal, 5 volt, peak to peak, with an offset of 2.5 volts. So actually this signal is going from 0 to 5 volt. If I were to put this down to ground, there's our ground reference right there, and then you can see it's going from 0 up to 5 volts. It's a 10 kilohertz signal, not that that's important because our sample rate is going to be really slow compared to that. But anyhow, I just wanted some kind of a reliable signal that I could tell I was getting good samples. Now, this is the signal generator coming out here, ground and signal to A0 on the Arduino. This is the scope leads, again ground and A0 on the Arduino. So that's a pretty simple setup. The Arduino has a SD card shield on it. So we're going to sample this analog signal on A0 and write it to the SD card and go around and around that loop. And there are no delays in the loop, as you'll see in just a little bit when we look at the sketch. So the main thing affecting how quickly we can sample, or the sample rate, is going to be the time it takes to write that information to the SD card. We're going to send out on the serial port the milliseconds that it takes to go around that loop one time. That's going to be a while loop, and that'll be our sample rate. Here's a little diagram showing the setup. Pretty straightforward. We've got a signal generator here, and he's connected to A0 on the Arduino, and of course to ground too. And then we've got the oscilloscope just for monitoring. Want to make sure that it's the right size signal for the Arduino to capture properly. It goes from 0 to 5 volts sine wave. So what we expect to see in our captured data is 0 to 1024. So that's the setup. We'll have a look at the sketch here in just a minute, but let's just take a look at the serial monitor. This is with the Class 4 SD card in the shield. Let's just see what we're getting. What we're doing now is timing how long it takes to get around the while loop and store that sample. Here we go with the serial monitor. Okay, looking like 2223. I only took 100 samples. Okay, so what do we got here? 22, 23, 24, 26, 25. So looks like right around 25 samples, or 25 milliseconds per sample time around the loop. So if we divide 1,000 by 25, we get 40 samples per second. So that's approximately 40 samples per second with a Class 4 SD card. We'll have a look at the Class 10 card, and of course we expect that to get around the loop a little quicker than this one. But for right now, while we still have this running here, let's take a look at the sketch. Some comments here at the beginning. The only thing affecting the speed to get around the loop really is writing time to the SD card. So we include the serial library, we include the SD card library, chip select of 4, unsigned long for previous milliseconds. This is going to be part of timing it. Now, I only wanted to take 100 samples just to get around, get the thing done quick. So putting everything in the setup a portion, and then the loop is going to be empty. So we open serial communications. Serial begin at 9600. We wait for it. Here's a while loop. We're waiting. Well, it's not there. And then once it is there, we go ahead and say initializing the SD card. And then we make sure that it's there and can be written to. And if it's not there and can't be written to, then we're just going to say serial print a line, card failed or not present. So we know there's a problem that we have to fix. Okay, then we say serial print a line, SD card is initialized. So now we're ready to get on with our sampling. Because I want a nice clean data log, that's what I'm calling the the file where we're saving the captured data, because we want a nice clean one. If it already is there, which it's going to be pretty much, we go ahead and delete it so we can start clean. So if datalog.txt is already there, go ahead and delete it. This will guarantee we start off with a clean file. So that's the comments that I make there. And of course, if we don't delete it, it'll just append the new information to the old file, which I don't want. If the file already exists, we're going to print out a message just to let us know datalog.txt exists, and then we go ahead and remove it. If we've removed it, if it's true, then we print out a line saying successfully removed. So we know we've gotten to that point. And then just to hold my hand a little, I say, now we're going to start sampling. Of course, else, if something went wrong, we say that we could not remove the file right here. All right, now we're going to capture 100 samples. So I starts out at 0, and we have a while loop here. And this is the beginning of the while loop. If we go down, you see the ending is right here. And after we go through that while loop and we drop out of it, then down at the bottom we say sampling is finished. So we know it's finished. I'm going to do something similar for capturing out in the field, lighting an LED when we start sampling and lighting a different one when we finish sampling, because out in the field I won't have a serial port. But anyhow, let's go around this loop one time. While I is less than 100, we're going to do this. We're going to increment it, I equals I plus 1, and then we go ahead and take our reading, analog read 0, I call it sensor per analog read 0, and then we create the file on the SD card, and this data file is going to be SD open, going to be called datalog.txt, and it's a write file. We can write to it. Now, if it's been successfully opened, we go ahead and do that. So if data file, we go ahead and print to the data file the sensor value. And then we close the data file again. So that's one write. Then we want to have this thing called time passed. Okay, so it's unsigned long, the time that's passed since the last reading. So that's the interval in milliseconds since the last sample was taken. So that's right here. Time passed equals milliseconds minus previous milliseconds. And we print that out to the serial port. Then we update previous milliseconds equals milliseconds. Else, we got a problem. Okay, so serial print, error opening the data log. And then we have our serial print finish sampling. And as you can see, when we drop down to the main loop here, it's empty. So setup is done one time, loop goes on and on forever, so we get stuck in that loop at the end of sampling. Okay, so that's the program. Once again, let's watch it run. And again, we're getting 24, 25, 26. And so here's the line sample finished, so I know we're done with that. And right now, the Arduino is sitting in the main loop, going around and around. Okay, we're going to go ahead and swap out the card for a class 10 card and see what we get there. Okay, as you can see right away now, we're about 20, 19, 21. If we divide 1,000 milliseconds in a second by 20, we get 50 samples. So it appears that, this is pretty approximate, I know, but it appears that with a class 4 card, we're going to get about 40 samples a second, and with a class 10 card, we're going to get about 50 samples per second.